Hi, I'm Arturo, and I'm civil engineer. I work in Scan-to-BIM workflow, and I provide BIM coordination consulting. And with this scanner, I didn't just map a structure. I helped answer a real safety question. Will this structure hold fit equipment filled with water during a fire? In this video, I will take you from a some-minute walk through a tight, multi-level industrial structure to a complete structural model analyzed for that exact scenario. This is the FJD Trion P1. The scanner does the heavy lifting. It captures the trigonometry of the wall with a spatial fidelity that would be impossible by hand. And for the detailed data, the structural analysis requires profile thickness, connections. I verified those directly in the field. The scanner for the wall target measurement for the fine detail. That way, the model is not just good looking, it's reliable to calculate with. Capturing reality was the fast part. What is interesting is everything that reality let us answer. And it wasn't just a one structure, it was 6 industrial dryers across 2 facilities. Here I am walking a 3-level dryer with some very tight areas and scan it complete in a single pass. As a backup, I placed targets on each level in case I had to register level by level. But in processing, the 3 levels run closed so well that I didn't need to register anything separately or join clouds with targets. The P1 is an integrated panoramic camera, so as I walk I capture geometry and color at the same time. These are the first 3-point clouds, and I capture all them in a single day. Each run was different. The bigger dryers took between 16 and 19 minutes, and the small ones 7 minutes. That's an entire multi-level structure capturing the time it takes to drink a coffee. With the clouds processed, the Pro version of the software FJD Trion model has a drawing model where I trace the silhouettes directly. The mechanical equipment, the chamber perimeter, the levels. From there I export to CAD to bring it into Revit with general dimensions ready to go. For specific measurements, you don't always need to model first. The software has a fusion view that combines the point cloud with a 360 panoramic image, so I can place myself inside the survey and pull exact measurements right from there. And one thing speeds everything up, the online viewer from FJD Cloud. From there, the team can view the survey and take measurements without the desktop software installed. That let us split the work and finish the modeling in record time. Another method we use is model straight from the cloud. Thanks to FJD Trion software compatible formats, I link the point cloud inside Revit and model right on top of it. Here you can see the model taking shape with the real cloud behind it as an exact reference. I have already shown you the point cloud of the first facility. Now I will show you the one for the second. And after each point cloud, I will show you the resulting 3D model. The second facility followed the same workflow. I scanned in minutes to then be modeled in a few days. And these are the model of the first 3-point clouds that I showed you at the beginning. And from that model come the deliverables, floor plan, section and 3D views, 6 dryers only in 2 days field capture. Here's the end of the journey. With the model, I analyzed the structure into another software including seismic and the critical fire scenario, with equipment full of water. What you are seeing is the actual deformation of the structure under that load. The result, lateral displacement and steel stresses, stayed within the code limits. The steel superstructure was verified as safe for the scenario. That was exactly what the client needed to know. I'm Arturo, and scanning reality is just the beginning. Thank you.